Let's demonstrate some of these principles in MATLAB. I'm going to create a point in the world, and it's going to be at coordinate 0.2 meters in the x direction, 0.3 meters in the y direction, and it's going to be 5 meters in the z direction. Now, z is the direction along the axis of the camera, what we call the optical axis of the camera. So this is a relatively small object 5 meters away from the camera, and a world point is always a column vector. So there it is. Now I'm going to create a camera object, in fact a central camera object, which does the particular projection that we just learned about, and it's got a focal length of 8 millimeters. Okay, so here we have created in the workspace now a central camera projection object. This object has got quite a lot of methods, and we'll have a look at some of those. So the first thing I'm going to do is to use this camera object, and I'm going to project my world point, capital P, to the image plane. And what you see here is that we have got some very small numbers. These numbers are less than half a millimeter. We've taken our view of the world and we've made it much, much smaller and projected it onto the image plane. This is where the piece of film would be, or this is where the digital camera chip would be. In this projection, there is no notion of pixels. We've just taken an image in the world, and it's described in terms of its size and its distance in units of meters. We've projected it to the image plane, and this is talking about the size of the image, also in units of meters, a very small number of meters. Now let's turn this into a digital camera. Let's introduce the notion of pixels. We're going to create a new camera object. We'll basically recycle this line, and we will tell it that the pixels are 10 microns on a side. So the pixels are square, 10 microns wide, 10 microns high, and our image plane has got a resolution of 1024 squared. So this is a megapixel camera. And now if we look at the parameters of our camera object, we see here, we can see the focal length. Here we can see the size of the pixels, the number of pixels, 1024 by 1024, exactly what we entered on the command line. And this parameter, the principal point, which is where the optical axis pierces the image plane, is smack in the middle at coordinate 512, 512. Now that I have my digital camera object, we can redo that projection that we had before, project the world point P, and this now is the coordinate of that point in units of pixels. Another method of the camera object is to actually plot these on a graphical image plane, and here we can see where that world point has been projected to on the digital camera's image plane. Some other methods, we can look at the camera's intrinsic parameters. This is the intrinsic parameter matrix. This is the overall camera projection matrix. We can pass an additional option into the project function. We project, the first argument again is our world point. And now I'm going to shift the camera a little bit, and I'm going to tell it to shift the camera 0.1 meters in the x direction. Given the camera's coordinate frame, that's a shift of 0.1 meters to the right. I'm not going to move it in the y or in the z directions. So now what we see is that the projection is different, and we would expect that. We see that the u coordinate has been reduced from 544 to 528, and that's what we would expect. If we move the camera to the right, we would expect the image plane coordinate to move a bit to the left. We can, instead of translating the camera, we could rotate the camera. So we could rotate the camera around the y-axis. Now the y-axis points downwards, so if I do this rotation of 0.1 radians around the y-axis, that's essentially rotating the camera towards the right. And if we do that, here's the projection again, and as we would expect, if I rotate the camera a bit towards the right, the pixel in the image will move a bit towards the left on the image plane. Let's consider a more complex example, one where there are multiple points in the world. To create multiple points in a grid pattern, I'm going to use the toolbox function, make a grid, and I want a 2x2 grid, and the points are spaced on 0.2 meter centers, and I want the center of the grid to be at a coordinate 1, 2, 0. So this is a grid in the xy plane. The center of the grid is offset 1 meter in the x direction and 2 meters in the y direction, and all the points have got a z coordinate of 0. So here are the set of points that I have just created. In order to view these 4 points which lie on a ground plane, I am going to create a new camera. It's a central projection model camera again. I'm going to set default camera parameters. So this is default values for focal length, image plane size, and pixel size. And I'm going to explicitly give the pose of the camera. So our 4 points are lying on the ground plane. So in order for my camera to be able to see them, it needs to be somewhere up high looking down. So the first thing I'm going to do is to place the camera 4 meters above the ground. So this is a translation of 4 meters along the positive Z axis. And then I'm going to rotate it around the Z axis by pi on 3 radians. And then I'm going to rotate the camera around its y-axis so it points down at the ground. So it's rotated around the y-axis by pi radians. Bear with me, I've worked this example out and these numbers should give something like the right result. First thing we're going to do is to project those 4 world points onto the camera's image plane. And here we have the coordinates of those points. So they clearly lie within the field of view, and we can actually have a look at those 4 points. We can plot those, and that's what the image plane looks like. So they're just in the edge of the field of view of our camera, which is looking down. Now let's try and get a 3D understanding of what's going on here. So I'm going to create a new figure. I'm going to call it figure 2. And another method on the camera object we just created is called plot camera. What that does is to render a 3D model of the camera into a graphic. And the other thing that I'm going to do is to add to this graphic the 4 world points given by capital P. And I'm going to render them as little spheres with a radius of 0.05 meters each. So I've created this little scene. I'll turn a grid on to make it a bit easier to see. Now, if I turn on my 3D rotation tool, I can spin this around. And here we can see what it looks like. Here are the 4 points on the ground plane that I created using the make grid function. And up the top we can see the camera and we can see the axes on the camera. The camera's a little bit small. We can zoom in and have a look at the camera. There it is. There it is there. We can see its X, Y, and Z axis. Zoom in a little bit more perhaps. And we can see there. It looks a little bit like a camera. It's a box with a cylinder on the front. These are just a few examples of the many things that you can do using the camera classes within the toolbox.